that in a second. And our next speaker, who should have his talk up soon, is Dan Olmsted. Also, he's the NEWA coordinator, the Network for Environment and Weather Applications coordinator in New York State Integrated Pest Management. And he's going to talk about watering, weather, irrigation, and weather stations.
So yeah, I'm really excited to be a part of this conference. I coordinate a program called NEWA, but I'm really going to step back today because the organizers asked me to talk about water and irrigation and weather stations and how it all ties together when you're managing your garden or maybe a community garden or something like that. So if you could go ahead and launch the first question. I'm going to explain what I'll talk about in the next few slides. So I'm actually not going to be talking about specific brands of weather stations, what kinds of sensors you can get on weather stations. I want to talk about them more in the context of a system. So as you're answering these questions, I'm going to go forward and first talk about water cycles. So if you think back to high school and college, maybe we talked about those. If you're a master gardener, maybe you've heard about that. But I want to talk about weather and water availability at different scales. So, we have a regional scale, so like New York State. Then we have like a local scale, maybe your city or town or village. And then we have landscape level. So what's happening in your backyard? What's happening in your neighbor's backyard? And so that's the approach I'm going to take today. I want to leave time for questions at the end. If you do have specific things in mind you want to talk about, that'll kind of be the time where we can get technical and a little bit nerdy, so to speak. But let's see here. So I'll give it another second or so. Let's go ahead and end the poll. And this is just a general question. There's no right or wrong. It's pretty evenly distributed among these first four options. So the news, a website, an app, a rain gauge, and then a few people actually have a weather station. So it's a really interesting perspective. If you're comfortable with where you're getting your information and you feel that's reliable, it's perfectly okay. So I really just wanted to get a sense of how people find information about rain and how that plays into your gardening efforts. So let's go ahead to the next slide and you can actually, yeah, there we go. Okay, so when we're talking about water and irrigation and what your plants need, it's really, in my mind, a three-way interaction. So, we have weather and then we have microclimate, which I'll talk about in a minute. But that overlays with, all right, so we had 2 inches of rain, which then goes into your soil. So now we're talking about soil water. But then even as a third step, once that water is in your soil, what are the physical characteristics of that soil and how does that translate to what's actually available for plants to be productive? Next slide. So there's this idea, again, at a regional scale, I'm going to use as an example of physical barriers that cause differences in weather patterns. So the example I have up here is a mountain range. So if you've been out to the Pacific Northwest or really anywhere, even in the Appalachians or locally here, we have this effect of a rain shadow. So the prevailing winds push weather in a certain direction. There's basically this wall of a mountain that is a barrier and all that precipitation comes out. Now on the other side, conditions are very different. And that's what this slide is getting at. Next slide, please. So this is actually one of the Hawaiian Islands, and this is a real life example that shows you in an extreme case how these types of physical barriers can impact water availability. So the upper right corner is the direction that prevailing winds are coming from. So you you have a tropical climate on one side of this mountain range, and on the other side, you literally have very dry desert-like conditions. All right, next slide. So now I want to bring this to where we are. So in New York State. This is actually a picture of Canandaigua, New York, at the north end of Canandaigua Lake. And the next few slides that I'm going to talk about, I have a garden in my backyard, things that influence my garden that maybe we aren't always thinking about. So if we look at this picture, which is from Google Maps, actually, you can do this yourself with your own neighborhood. There's a lot of things in the landscape that could have like a larger scale effect at this level that we're considering. So folks who are maybe close to the lake, who are on a hillside, might have slightly different conditions than somebody else who lives uptown where I am. And in the winter time, maybe conditions are a bit moderated along the lake versus a little bit more extreme up on top. So now click the next slide, please. We're going to zoom into where that rectangle was. And we're going to go a little bit closer here. So now if we look at the neighborhood level, we start to be able to consider things, again, think about these physical barriers that might influence wind patterns or rainfall patterns, things like that. So on the left side of the screen, you've got a big wooded area, and then you have houses that are lining that wooded area versus on the right side of the screen, there's a lot more pavement and open area. So how are these things going to influence conditions in your own backyard? Next slide, please. And then finally, this is about as close as you can get. Now we're looking at local conditions. So if you look at each one of these circles, what is happening in each individual backyard that might be similar or different to others? So in the top left-hand corner, we've got a big open area. So if somebody were to put a garden in there, how is that going to affect rainfall? How is that going to affect heat accumulation? Things like that. If we go down below that, that backyard is mostly shaded and there's a really tall tree line. And so maybe airflow is going to stagnate a little bit. The left side there is from the west, and that's where our prevailing winds usually come from. In the middle there, this is my house. So I'm not spying on anybody, but you'll see that we have a fence in the backyard. So that fence is going to have a similar effect to that wood line. It might be warm in my backyard, but I also don't have any airflow. And so Marion was just talking about certain diseases and, what do we need to consider for ideal disease conditions? I can tell you that I have discovered I get more disease pressure because I don't have any airflow at all. And then finally, just one last example in the bottom right corner, this backyard is on the south side, but it's also shaded. So again, things we need to consider as we are managing water and understanding water. All right, next slide. And if we could put up the next question. So which of the following creates a microclimate in your backyard? You can choose as many as you like. And I'll just give this a few seconds here. Okay, perfect. Just a few more seconds. This is looking good. Just 2 more seconds here. And I think we've got a good sense. So I'm going to end the poll. And it's pretty evenly distributed. So this was a trick question. These all create microclimates. Think about that first picture I showed you of Canandaigua Lake. Well, at a really high level, that body of water creates conditions locally. So a pool is going to do the same thing. If you have an in-ground pool surrounded by a fence line, you're going to have a really high humidity environment, which is going to impact evaporation rate and all sorts of other things. So I simply wanted to add that question to try and give you some more perspective. All right, next slide, please. So I mentioned it before, when we talk about rain and weather stations and irrigation, it's really a matter of looking at this as a system. So weather stations are really useful for understanding how much rain you got, but it's not the only option. And in the next slide, we'll just talk about that really quickly. But once you understand or have a good sense of what the rainfall amount is, you need to ask yourself a follow-up question of how much of that is actually available in my soil. And then the final step is, well, based on my soil type, how much of that water is actually available to my plants. Next slide, please. So thinking about that big circle I had on the previous screen, we get in the summertime, a regional system that comes through and it dumps some water, and everybody gets really excited. Oh, we got 3 inches of rain. That should be really great. Or, oh, I caused flooding. For your own gardening purposes, in some way, you want to understand you want to have a sense of how much water you got. And there's a lot of ways to do that. So there are pictures of weather stations up here, but you can just as easily have a manual rain gauge in your raised garden or in your plot. And that gives you a sense. If nothing else, sometimes you can literally pick up soil and just kind of do the hand test. Is it saturated? Is water flowing out when I squeeze it, or is it really dry? So that is the first step. Next slide, please. The next step, though, and I think this is really important, part of this conversation is understanding your soil type. I have just 2 examples here of very different soil types. So on the left-hand side, I've got a heavy clay soil, and on the right-hand side, I've got almost a pure sandy soil. Now in our gardens, we can get an inch of rain, but the way that water is held by your soil is going to determine the availability of that water to your plant. Next slide, please. And so I want to ask one more question here. And then when we're done with this, I'll finish up the rest of my slides. There it is. So think about those 2 pictures I just showed you. Which type of soil has a higher water holding capacity? Okay, I'll give it about 3 more seconds. Okay, let's go ahead and end the poll. So most of you said a cubic foot of clay, and some of you said a cubic foot of sand. So let's talk about this. Next slide, please. So what I have here is an illustration at a microscopic level of these 2 soil types. So sand, when you're looking at it under a microscope, has really, really big particles. And so in a given volume of soil, you might have something that's representative on the left-hand side. In that same volume of soil, if we're looking at clays, you're going to see many, many, many more very small particles. And so to answer the question that I just posed, clay soils have a higher water holding capacity because there's more surface area. So I couldn't think of a good way to represent this 3-dimensionally, but if you think of these as little spheres, the total surface area of those spheres you see in the sandy soil is actually a lot lower than the surface area of those hundreds and hundreds of little clay particles. So that's something really important to consider. Next slide, please. All right, so with that understanding that, in a very basic level, sandy soils hold much less water than clay soils, I'm showing you a picture of something called the soil texture pyramid. You know, these are the two extremes, but you can get different combinations of these. And there's actually a third type called silt. So you can send your garden soil to a laboratory for a composition analysis, and it'll come back and it'll give you like the percentage of each of these types. So we have sand and clay, which I just mentioned, but we also have silt. And so depending on those percentages, you can actually classify your soil. I'm telling you this because clay soils have a really high water holding capacity, but they also have this annoying ability to not give that water to plants if you put your seeds in there, if you put transplants in. And so understanding this interaction between how much water did I get, what soil type do I have, and you know, how difficult is it going to be for my plants to take the water out of that soil type is critical to understanding the overall, you know, the overall view of what water is going to be available. All right, next slide. Whoops. Okay. So in this last slide, I just want to summarize what I've talked about the last few minutes. So the question is how to interpret water availability in your backyard garden. There are 3 steps in my mind, and you know, it's a little bit more nuanced, but number 1, how much rain did we get in our microclimate? So, you know, if you're looking at the regional weather report on the news, how does that translate to your yard that is fenced in and has a pool? And in addition to that, how much of that water actually gets into the soil? Number 2 ties right in. Once it's in the soil, you know, given your soil type, how is that water going to interact with your physical soil characteristics? And then finally, number 3, if you have a really high clay soil, how much of that water is going to be available for healthy growth of your plants? Last slide, please. Now, with all this said, I think it's really important that if this is a lot of information and it's new to you, or even if you're experienced, we have a lot of resources statewide. Of course, we have the New York State Integrated Pest Management Program, but your local extension offices and their respective master gardener programs have a lot of knowledge and experience that, and they may be able to help you navigate some of these questions. If you've been having problems, you know, with dry soil or saturated soil, or your plants just don't seem to be doing well and you think it's related to water availability, I would absolutely reach out to any of these groups for resources, because hopefully the message I'm driving home at this point is that irrigation and water and rainfall is not quite as straightforward as you might think at first. So with that, I think we're almost at 9:50, and if people have questions, I'd be happy to answer them. If you do want to talk about weather stations, I'm happy to take questions about that.
You have a question there already. Can you recommend a rain gauge?
Can I recommend a rain gauge? So if you're looking for just like an analog rain gauge, I think any that you get at your local home and garden store is fine. If you're looking for something electronic, it depends on your budget because there are a lot of options out there. I think where I would start if I was gonna you know, just get something inexpensive for my backyard, I probably wouldn't spend more than $100 on it, and I would expect to replace that every 2 or 3 years. I would also look at online reviews because there are a lot of companies out there. There's a lot of off-brand things. You can get them really cheap on Amazon, but I think sometimes there's a trade-off there. So I'm happy to follow up with anybody offline if you need to have some more guidance on that. But I think there's a lot of factors to consider.
Dan,
it really
what does
just
an
needs.
electronic one do?
What's that?
what does an electronic, I've never seen an electronic rain gauge. So does it report somewhere or does it give you a digital readout?
Yeah, it absolutely does. So what happens is, so you have what's called the bucket. It's a standard size. I think the National Weather Service standards are like an 8-inch diameter bucket. It collects everything into a funnel, into a small hole, and then it literally has a little lever inside. Usually it's like 0.01 inches per tip. And so it measures the number of tips. And then from that, it can calculate the volume of water that has come through that funnel system. And then whatever brand you get, they usually have an online system or an app. The one I have in my backyard, it sends a signal to my kitchen. It's not hooked to the internet, but I get reports, and that little desktop unit just it saves the rainfall amount digitally. So as long as I don't unplug it, it gives me a cumulative total, and it gives me little summaries and stuff. See, there's a lot of iterations, which is why I chose not to get into it. So it's like, I see a weather station as being just another tool in your back pocket, like a hoe or a shovel or a wheelbarrow. And so it depends on what you're willing to spend, how important it is to you to have 0.01 inch accuracy, because maybe you just need to know, I got 1.5 inches, or I got 5 inches, I'm in trouble, I need to call my insurance agent.
How about placement? We've got a couple of questions on placement.
Yeah, so if you think about what I was saying regarding microclimate, generally you want to place them away from those barriers. So you don't want your weather station or even little manual rain gauge to be right next to a fence line, because if it's windy, that rain might blow right over your rain gauge and it won't even register. If you put it out in the middle of your yard, which is usually bright and sunny, that water might evaporate before you're able, if you're using a manual gauge, it might evaporate before you're able to check it. So you'll come home and say, oh, I only got 1/4 inch, when you didn't realize it was like 95 degrees at lunchtime, and maybe 1/2 inch that was in that rain gauge evaporated before you saw it. So that is an advantage of an electronic system, is that it measures it right away. The trade-off is that you've got to pay $150 versus $5 for a plastic one.
How about effective methods to affect clay soils to make water more available to plants?
Yeah, so this is getting a little outside of my area of expertise, but you can definitely come up with a plan to amend your soil. There are certain things you can plant that the roots will aerate it, or you can like have a composting plan where you add some compost every year. That's a question I'm going to leave to people who have more expertise than me, like master gardeners, master composters. I bet folks on this call, you've all been gardening for more than 4 years. I bet you all have great ideas. So I'm kind of going to leave that one for the experts.
And then I'll give you one more, the most accurate weather app, which I think is maybe an unanswerable question, but go ahead.
Yeah, so it depends on what your criteria are. Again, if you're going to use an app, that leads to a question of, are you collecting your own data or are you using publicly available data? If you're using your own data from your own weather station that links with some sort of app, I would say it's reasonably accurate as long as you're taking care of your weather station. These public apps, it really breaks down quickly with this question, because some apps are just pulling whatever publicly available data are available. Like your neighbor down the road who hasn't taken care of his weather station in 3 years is reporting to Weather Underground. It shows up just like any other one, but you don't know how accurate that is. I would say an app that gives you a representative sample in your area. So let's use Weather Underground for an example. Don't look at one data point in your neighborhood. If there's like 2 or 3 or 4, or even in your village or town or city, try to look at a collection of them as opposed to a single point, because that single point, there's always statistically a little bit of error. But if you look at 4 or 5, you're going to have a sense, okay, well, this one says 34 degrees, but this one says 37 degrees, and this one, you're going to get a sense of what that middle point is. And the same is true for rainfall.